Our first speaker in this particular session is Dr. Victoria Arrandale. Dr. Arrandale works at the Occupational Cancer Research Centre in Toronto, Canada, and is an assistant professor in the Dalalana School of Public Health at the University of Toronto. She holds a Master of Science in Occupational Hygiene and a PhD in Medical Science, Occupational Health. Dr. Arrandale's work to date has considered skin and respiratory exposure and disease in a variety of occupations and industries. Her current research focuses on the evaluation of skin and inhalation exposures in the emerging industries of electronic waste recycling and nail salons, as well as the improvement of exposure assessment in an ongoing cohort study of hard rock miners. They're fairly opposite type industries. Dr. Arrandale's work is supported by a Career Development Award from the Canadian Cancer Society Research Institute and grants from the Ontario Ministry of Labour. Her topic today, skin exposure in the workplace, recognition, evaluation and control. Please welcome Dr. Arrandale.
Okay, thank you very much. First, I'd like to say a thank you just to the AIOH and Simon for the invitation to come down. This is the first time I've been to Australia, and it's really been a wonderful experience, and I'm looking forward to exploring a little more over the next couple of days. So, to the talk at hand, I'm going to talk to you about skin exposure in the workplace, and hopefully everyone can walk away with a bit more information. My outline is really, I'm going to start by describing the impacts of skin exposure, just to sort of give you a bit of why I think it's important to think about skin exposure, maybe in more cases than you do now. I'll review some of the methods for measuring skin exposure and the considerations that need to be thought about when you're collecting measurements or thinking about collecting measurements of skin exposure. And then I'll finish up with some practical approaches for how I think we can improve exposure control related to skin exposure. And they're a bit simple, but I think they can be effective. So let's get started. So just a reminder, the skin is the largest organ in our body. It is a barrier. It's intended to keep the insides in and the outside out. But it also has to be permeable. So these are competing goals, really. And that barrier is quite important for skin exposure. When that barrier is impaired, we can have increased uptake through the skin root. So we do want to keep an intact barrier, and we also want to keep the exposure off the skin, obviously. It's an immunologically active organ. We have a lot of immune cells in our skin that function in allergic responses as well. And if we think of the relationship between skin exposure and health effects, we are still interested here in all the types of exposures, chemical exposures, physical exposures, and biological exposures. They're all relevant. And health effects can occur both locally and systemically. On the exposure side of that relationship, we do have the allergens, which I mentioned, also irritants, acids and bases can cause injuries. Pesticides and solvents are some of the more common exposures that we've thought of for uptake through the skin root. But there are physical hazards, so solar UV radiation is one that you are very familiar with here. But also friction or mechanical exposures can result in types of dermatitis on the skin. And there's also biological agents that might be important in some workplaces in terms of causing infections. And I want to highlight the importance of wet work as an irritant. It's not one that we always think of immediately for skin exposure, but it is hugely impactful in terms of its effect on working populations. On the health effects side of the equation, I said, we have local effects and we have systemic effects. Locally, skin disease is the big one, and within this group, contact dermatitis is really the heavy hitter. There's irritant, which is the most common form of contact dermatitis, and then allergic being the smaller or less prevalent form of contact dermatitis, but we can also have skin injury and we can have skin cancer. Systemically, we see things like cancer in non-skin sites, but in a variety of locations. Neurological impairment can occur, as well as acute toxicity, although this is thankfully rare. So if we think, and we want to look just for a moment at skin disease and how big of an impact this is, it's actually quite common. about 10% of occupational disease, these are not current numbers, but it's very difficult to get a handle on disease prevalence, as I'm sure everyone in the room is aware, but 7% of all occupational disease in the European Union in 2005 was thought to be skin disease, and 12% in the US a few years later. And these numbers obviously don't take into consideration the underreporting that happens in occupational disease in general, and specifically in occupational skin disease. It's also got a very high prevalence within working populations. So you can see in the list there anywhere from 20 to 40% in a selection of workplaces. These are mostly wet workers, with both the construction workers and the healthcare workers have other exposures, but it's quite common. So in workers that have skin exposure, the prevalence of skin symptoms and the prevalence of skin disease is actually quite high. And the impact of skin disease can also be fairly severe, and I think we often think it's just our skin, it's just a rash, it will go away. And in fact, for a lot of people, it progresses quite significantly. You can see this photo in the bottom right-hand corner is a worker who has allergic contact dermatitis, and you can imagine the pain and the discomfort that goes along with that, as well as the inability to do their tasks of daily life, as well as their work tasks. And so we do see decreased quality of life in workers that end up with occupational skin disease. It has impacts on personal relationships. Anecdotally, Dr. Holness, who did this work in the clinic, they do hear people are embarrassed about their skin. They don't want to have their hands seen. So there are impacts on their personal life, but there's also work impacts. So their finger movement is impaired. Their ability to grip things is impaired. And so these are potential safety hazards among folks that do have skin disease. And at the worst or the most extreme cases, these individuals do have to change jobs. They cannot continue to do the work that they've been doing, and they may actually be off work. So in Ontario, where I'm from, it is absolutely a compensable disease, and they would be offered retraining if this was the case. So how do we identify skin hazards if we're in our workplace? Obviously, there's going to be some clear cases where we have contact or we can see the skin exposure happening. But in cases where perhaps it's not so obvious, we're going to look to things like our safety data sheets. We may look at skin notations that are out there in the resources for occupational hygienists. The AIOH has a skin notation, keeping in mind here that only 650 or so chemicals have been reviewed by the AIOH, and some of them not so recently. There's NIOSH skin notations that were developed in about 2009, I believe. And the NIOSH skin notations are particularly good, in my opinion, because they split up the effects. So they talk about systemic effects, direct effects, and the sensitizing effects as three separate notations. And there's also lots of other reference materials that I'm sure you use on a regular basis that can give you information on whether you should be worried about the chemicals or the hazards in your workplace in relationship to skin contact. And when you're thinking about whether things are a skin hazard, I think thinking about the pathways of exposure becomes important. So having direct contact is probably the one we all think of first. So immersion, so hands, generally hands, going right into the compound or the exposure of interest, or contacting it when it's on the process or on the materials that are being worked with. But there's also other pathways through which exposure occurs to the skin. There's splashes, which are, admittedly sort of potentially hard to predict, but also deposition from the air onto surfaces and onto the skin. And surface contact, so skin contact with surfaces that are dirty or have been contaminated. And almost more than 15 years ago now, a group that was comprised of folks from the UK, from the Netherlands, and from Denmark came up with a conceptual model for skin exposure. And it was updated recently to include the oral cavity in terms of the hand-to-mouth contact that can occur. So it does actually show where the inhalation exposure will occur. I'm going to step to the side here. So it shows where the inhalation exposure occurs from the air compartment. It shows where the uptake from the skin would occur from the hands or arms. This could be other parts of the body here, and the ingestion. And what the idea here is that in each of these boxes is a compartment where we might be able to sort of measure something, but it also allows us to think about what is contributing to skin exposure, or how things might be getting onto workers' skin. And I'll just click through quickly here. So in terms of the direct contact, it can come directly from the source to the skin, or it can act through the clothing or the PPE layer. And we'll talk a little bit about this later in terms of prevention. But when we think of deposition, both the surface contact or the surface contaminant compartment as well as the air play a role, so that the exposure leaves the source but can eventually get to the skin through several different pathways. And so thinking about these compartments and how each may be important in terms of measuring skin exposure or preventing skin exposure can be quite helpful. And just the last one with surface contact, the interaction between the surface contamination in the air coming down onto the skin or via the PPE or clothing layers. So why might we want to measure skin exposure? Well, we've seen a couple of very nice examples at this meeting in terms of wanting to understand routes of exposure, and this may arise because we have biomonitoring results that cannot be explained from air levels alone. We may want to understand the pathways of skin exposure, so thinking of the previous diagram and thinking about what compartments are important and where might we be looking to reduce levels. We may want to assess the effectiveness of PPE, so measuring skin exposure underneath personal protective equipment and seeing what, in fact, if anything, is getting through the PPE. It may be to assess compliance with organizational limits, and we don't have regulated limits, but some organizations do have guidelines internally that they may be testing compliance with. We also do it in research, so we want to understand both the variability in exposure, where it occurs, but also the relationship between exposure and disease. And in reality, I do think that it's most often done in research studies, so folks, we know a little bit about skin exposure, but it's not something we do a lot, and in research, we are doing it, but for very, very different reasons than practicing hygienists are doing in workplaces. There are three main approaches for describing measurement of skin exposure, and they're removal, interception, and sort of in situ or tracers, fluorescent tracers. So I'll just walk through these one at a time. So when we're talking about removal techniques, this means collecting or sampling what has landed and remained on the skin, and it's done through things like wiping skin, washing skin, and tape stripping specific areas. And down at the bottom here, we have an image of some skin wiping that's occurring. So on the left, they're wiping what looks to be the whole hand. On the right, that's a template. They're showing a surface wipe, but what often is done is a template placed on the skin to ensure consistency, and that's really the key here. Consistency in the number of wipes that are done over the skin, the area of the body that is wiped, and the size of that area that is wiped to allow for comparison between the samples. And similarly with washing, where you're washing the exposure off people's hands, collecting the liquid, usually a mild solvent, and sending that for analysis, ensuring that the methods that are done, the technique that's followed is consistent from measurement to measurement so that you can compare the data points that you get. Surface wipes themselves are a type of removal technique, and they can be qualitative or quantitative. There are commercial products. I'm showing one there. I don't have any relationship with that company, but it's one I'm familiar with, where they're colorimetric swipes to show you whether your tool or your surface, in fact, is contaminated. And these surface wipes are telling you the potential for the surface contact route to contribute to skin exposure. They're not telling you specifically about the skin exposure itself, and they're a good tool for hazard identification, and they're quite simple, so they are a good thing to have in your toolkit if you're concerned about housekeeping practices or the potential for surface contact to contribute to your overall skin exposure. Tape stripping is probably the most invasive thing that can be done in terms of skin exposure measurement, and this literally is stripping the outer layers of skin so that that outer epidermal layer. The outer part of that is the stratum corneum, and taking off layer by layer of the stratum corneum and analyzing for what is in each successive layer of that skin. And here you are actually measuring what gets into that layer rather than what is on top of the skin. But there's some limitations here. It's quite uncomfortable for the folks that are doing it, or the worker that it's being done to, pardon me. And it is a snapshot, so it's telling you what's in the skin at that particular moment. It's not telling you how much has gone through that day, for example. So in fact, it may underestimate exposure in comparison to other methods. And one example here with isocyanates, a group compared an interception method, which I'll speak about in a minute, a pat or a glove method, and they found 300 times less exposure when they do a tape stripping method. And so this is expected, but it means we can't compare between the methods of dermal exposure measurement. Probably the most fun is using fluorescent tracers, something I've never done. And in this case, you're adding compounds into the process materials at a workplace. Work proceeds as normal, and then at the end of the day, you're using usually light to visualize where the exposure ends up. So you're going to put the workers in front of a lamp to see whether the exposure is on their hand, their neck, their face. And so it's going to give you sort of a semi-quantitative estimate of exposure. It's not going to give you a number, but it's a really powerful communication tool for workers who may not think that they have skin exposure when in fact they do have exposure. And interception is the third one. So this is collecting the exposure before it gets to the skin. And here it's probably methods people are familiar with, the use of patches or pads, analyzing gloves for what has been absorbed by the gloves workers are wearing. There is potential with interception methods to over or undersample depending on the sorbent that's being used and the exposure that's being collected. So you can saturate the sample so that you're missing exposure, but you could also have a sampler that's not collecting as much as the skin is. And so the challenge here is to find a device that mimics the behavior of the skin, and there's been a couple of attempts to do this. There's an example at the bottom of the slide there where they've put a membrane over a Gore-Tex layer over the activated carbon cloth, which is where the sample is going to be collected. And the idea is that those outer membranes behave as the skin would so that you're not oversampling for this particular exposure. We're also working on new interception methods. I'm working with a group in Toronto, Miriam Diamond's lab, and they're working with a silicone-like material that's worn as a wristband. It was originally designed as an air sampler. You can see the brooch on the person's lip or person's shirt. Someone put it on the wrist and then found immediately that the wristband doesn't correlate with air levels, perhaps not surprisingly to the hygienists, but these were analytical chemists and environmental scientists, and they hadn't thought about the skin as a route of exposure. And so we're now using this in some workplace studies to see how it relates to both air levels and to skin levels. And in fact, it's very highly correlated, over 0.9 for those who like numbers, with hand wipes and wipes on the lower arm. It's still quite highly correlated with air levels, but we're still doing a lot of investigation on this. But certainly this is a much easier method for getting exposure measures. And so if it turns out to be accurate, this will be a nice tool for us, at least in research, and potentially for others to have in our toolkit in terms of getting easy measures of skin exposure. There are also other groups that are working on developing glove samplers, as well as using cotton t-shirts and coveralls and things like this, finding easier ways to use materials that are already in the workplace as tools for assessing skin exposure in workers. But what about the challenges? And I think this is something I've heard a lot about talking to people over the last few days. And in reality, measuring skin exposure in the workplace is not straightforward. It's in fact quite complicated. There's a lot of questions that need to be answered before you embark on it. So what approach are you going to use? Which body locations are you going to measure? There's issues about where does exposure occur on the body, what's the permeability of the different body parts. Obviously, both of those things are going to vary. And the impact of PPE and hand washing, for example. When are you going to collect your measurements over the day in order to minimize the impact of these behavioral factors on the measurements that you're collecting? There's also no standard method. We can't turn to things like the NIOSH methods to tell us what to collect, how to collect it, and how to analyze it. And so we need to think more about things like the recovery efficiency of the techniques that we're using, our sample stability, what is the limit of detection, how can we ensure that our samples are going to get above the limit of detection, and any contamination issues that might arise. There's a lot of contact with particularly things like the skin wipes for the hygienist or the research assistant that's collecting the samples. So there's lots of potential pitfalls when we're doing skin exposure assessment. There's also no exposure limits. So what are you going to do with the data that you get out of measurement when you go and collect samples? What are you going to compare the results to? How will you decide if in fact there is a problem or not a problem? So thinking about these things in advance will help reduce the burden, I think, later on. But I think my message today really is that skin exposure control does not have to rely on measurements. So there are other things that you can do that will reduce skin exposure that don't involve collecting measurements. Even though there are still going to be situations where you need or want to collect measurements, it's not critical in terms of reducing exposure. And so when we want to control skin exposure, and we can't eliminate or substitute, I think that a good strategy really is to go back to those pathways and to think of that conceptual model and think about how we can block the pathway, essentially. So if deposition is a contributing factor, how can airborne levels be reduced? If it's direct contact with the exposure, can we enclose the process? Can we change the process so that the worker doesn't have to touch the material or the product that is covered in the material? For surface contact, can we improve housekeeping to reduce contamination? And if it's splashing, can mixing tasks be minimized, altered, or isolated? So really back to basics hygiene here, using the pathways as a guide. But of course, with skin exposure, we do often end up falling back on personal protective equipment. These are going to mostly gloves, but also shields, bodysuits, et cetera. And these are going to reduce exposure at the worker level. But I think I want to remind folks that PPE, particularly in the form of gloves, is the source of wet work exposure. So having your hands in gloves for multiple hours a day is in fact an irritant exposure. Gloves can be a source of allergen exposure, so latex gloves, also other rubber components in gloves, and they're a sink for exposure. So workers putting dirty hands into clean gloves that are then reused, the exposure can build up in those gloves and will continue to provide exposure even if there's no other contamination in the workplace. And obviously they can also impact workability, so thinking about the impact on dexterity, safety, grip strength, things like that. When we give people gloves, it's not simply enough to just hand them gloves and tell them to wear them. It is important to think about how we can train and educate people in the proper use of this PPE. And this will serve not only to reduce the skin exposure, but to improve or maintain the skin barrier, which is where I started in terms of keeping that barrier intact. And so there is some really lovely recommendations out of Denmark. And these programs have been evaluated, and they have these key features. And they talk about ensuring in the workplace that your gloves are protective for the exposure. And I've also heard over the last few days about this being a challenge in terms of the information available on SDSs and whether that is indeed correct or not. So that's a challenge. Ensuring that gloves are changed at regular intervals and that workers know when that is supposed to be done. Single-use gloves not being reused. Cotton gloves being worn underneath PPE. So these cotton gloves provide a layer between the skin and rubber gloves, for example. It increases comfort, it reduces the wet work effect. Not wearing jewelry. making sure that gloves are readily available in multiple sizes and styles as available or as possible. And then emphasizing the skincare piece and encouraging it. And this is done through things, proper hand washing, to water temperature, complete drying, and the provision of moisturizers, and the importance of skincare in maintaining that barrier function. It is simple and it's straightforward, but we don't do a good job either of educating folks or workers on their end of actually following through. Another piece that I want to suggest as a potential tool is secondary prevention, which is not our wheelhouse as hygienists. We talk about primary prevention, but for local effects related to skin exposure, so I'm talking about that contact dermatitis piece, the early detection of skin changes can be helpful. There are pictorial tools that are available for workers to use, for occupational health and safety folks to use, and they can increase awareness and the recognition of skin exposure and disease. And this has a benefit for the workers who end up getting disease, because early detection will result in better outcomes for them. But it also increases awareness among folks of the fact that skin exposure is a problem, and it will promote good skincare and ideally better uptake on the use of PPE in the appropriate settings. And you can use the secondary prevention information to inform primary prevention. So if you're seeing problems in one area of the workplace, that's an area that you may need to target for some primary prevention. And so this is a tool that's been developed by a physician in Toronto, and as you can see, left to right, normal skin, mild skin disease, and moderate severe skin disease. And what often happens is that folks look at the pictures in the middle and they think, oh, it doesn't look so bad. But in fact, there are early changes, the redness, the scaling, the dryness. So this is a sign that there is something going on with this person's skin that needs to be addressed. And the preliminary testing on these tools does show that workers underreport their skin disease when compared to dermatologists. I thought I would wrap up, I haven't got the red light yet, so I thought I would wrap up with with a quick, and then she flipped it, a quick example of what hygiene might look like in small businesses. And this is a different method of delivering hygiene. It's a project I'm involved in with community health centers and nail salon technicians, and it's using a train-the-trainer model to push information about skin exposure and skin exposure control to the workers who are in small businesses with really zero resources for occupational health and safety. And so it's occupational hygiene, occupational medicine, and community health. So I'll slip to my takeaway messages before I'm hooked off here. My takeaway messages are really that skin exposure is very common. It's often not on people's radar, particularly not on workers' radar. But that there are sort of very serious local and systemic effects that can result from skin exposure, and it needs to be considered in most workplaces. Quantitative measurement of skin exposure can be helpful, but it's really not always necessary in order to improve your exposure control, and that people should think about education and training as well as secondary prevention in your workplaces or the workplaces that you're working with. So thank you. I will put my email up here and take any questions, I think, at lunch, because I'm over time.